Hello, this is Mrs. Ward, and I'm going to go over the review worksheet for 5.1, 5.2, which is using the fundamental trig identities to verify equations. So the first one, you have tangent is equal to 2, and the sign is less than 0. They want you to use the VIP formulas to solve this. I'm willing to bet that most of you probably didn't use a formula. So I'm going to show you two ways for the first one, and then you can do what you want for the other ones. So this one, if I had the tangent is equal to 2, I'm just going to draw a triangle. I'm going to put an angle somewhere. If the tangent is opposite over adjacent, so if the tangent is 2, I'm going to make this 2, and I'm going to make this 1. I'm going to use the Pythagorean theorem, so 2 squared plus 1 squared is equal to my hypotenuse squared. So that will be 5 is equal to h squared. H is equal to plus or minus the square root of 5. But I'm putting this on my hypotenuse, so that is going to be a positive 5, because the hypotenuse can never have a negative angle. So now let's list the trig. Now that I have my triangle, let's list our trig functions. I'm probably going to have to change the sign here in a second, though. So my tangent is 2. The next easy thing for me to do is to do the reciprocal of tangent, which is cotangent, so that's going to be 1/2. Then my sine is going to be the opposite, which is 2 over the hypotenuse, which is the square root of 5. So that's going to make that 2 square roots of 5 over 5. But I go up here and I check that, see the tangent is negative, so I'm going to make this a negative 2 square roots of 5. So I better make that a negative 2, because the square root of 5 can never be negative. The reciprocal of tangent is cosecant, so I'm going to flip it over. I'm going to flip it over from here. So the square root of 5 over 2. If the sign is negative, the cosecant also has to be negative. Then to do my cosine, based on this triangle, I'm going to do the adjacent over the hypotenuse, so 1 over the square root of 5. So that will be the square root of 5 over 5. But if the tangent is positive, I'm going back to that all students take calculus. If this tangent is positive, that either happens in the first or the third quadrant. And the sign is negative, that eliminates the first quadrant, which means this triangle should have been drawn in the third quadrant, which means that my cosine also has to be negative. And then the secant is going to be the reciprocal of that, so negative square root of 5 over 5. And that's the first one if you drew a triangle. If you did not draw a triangle, and let's say you use one of your Pythagorean theorems, one of your Pythagorean theorems says 1 plus tangent squared x is equal to secant squared x. That's one of your Pythagorean theorems that you should know. So if I do 1 plus my tangent was 2 squared is equal to secant squared. So then 5 is equal to secant squared x. And then so square root of both sides. So plus or minus the square root of 5 is equal to secant. But again, since we said it was in the third quadrant, it's going to have to be a negative square root of 5. Oh yeah, up here that was over when I was right. Oh my. There you go. And then once I have the secant, I can find the cosine. The cosine is going to be the reciprocal, so 1 over a negative square root of 5, which will be a negative square root of 5 over 5. Then to find, if I have the tangent and the cosine, I'm going to say the tangent of theta is equal to sine over cosine. So to do this, I am going to say the tangent was 2 is equal to sine over the cosine, which is a negative square root of 5 over 5. So I'm going to multiply both sides by negative square root of 5 over 5. I'm going to get negative 2 square roots of 5 over 5 is equal to the sine of theta. And I'm hoping that matches what I had before, and it does. So either way, so you're either doing this triangle way up here, or you're doing the VIP formulas down here. So the next one, your sine, it tells you the sine of negative x is equal to negative 2/3. So remembering that sine is an odd function, that means the sine of x is going to equal positive 2/3. It tells me the tangent of x is equal to negative 2 square roots of 5 over 5. So if I'm doing this problem, the first thing I'm going to do is I'm going to find the cosecant. So I'm just going to take the reciprocal of sine and make that 3 over 2. If I'm finding the cotangent, I'm going to find the reciprocal. So that'll start off as 5 over negative 2 square roots of 5. Rationalizing the denominator by multiplying by the square root of 5 over the square root of 5. You can't fit that there. I would have started with 5 square roots of 5 over a negative 2 times 5. I'm going to leave it like that on purpose. And so I get my cotangent of x equal the square root of 5 over negative 2. So the whole thing is going to be negative. To find my cosine, I say I'm going to do, say, tangent is equal to sine over cosine. So then what I'm going to write is that my tangent is negative 2 square roots of 5 over 5 is equal to my sine, which is 2/3, over my cosine, which is what I'm looking for. Multiply both sides by cosine x. So I'm going to have the cosine of x times this negative 2 square roots of 5 over 5, and that's equal to 2/3. I'm going to either divide by negative 2 square roots of 5 over 5 or multiply by the reciprocal. I'm choosing to multiply by the reciprocal because it's easier for me to do up here. And when I do that, these will all simplify, and I'm left with cosine of x. And then here, the 2's will simplify. And so I'm left with 5 over 3 times the square root of 5. And this is negative because of that negative sign. Rationalizing the denominator, square root of 5, square root of 5. So that's 5 square roots of 5 over 3 times 5, but the 5's will simplify. So the square root of 5 over 3, and that's going to be negative. And then the secant is a reciprocal of cosine, which will be 3 over the square root of 5, which is negative. And then so it's negative 3 square roots of 5 over 5 would be my final answer. Okay, and then we put one more on there. I think we put one more on there. Yes, we did. I didn't put it here. The next one is you have the cotangent of theta is equal to 0.26. The sine of theta is equal to negative 0.97. So the first thing I'm going to do is I am going to find the reciprocal of cotangent, which is tangent. And to do that on my calculator, I'm going to take 1 over 0.26. And when I do that, I get the tangent of theta to be equal to 3.846. I'm going to do the reciprocal of sine, which is cosecant. To do that, I'm going to take 1 over a negative 0.97. And when I do that, I get negative 1.030. Then to find the cosine, I'm going to stick with my tangent of theta is equal to my sine of theta over my cosine of theta. So my tangent was 3.846. My sine was negative 0.97, and the cosine is what I'm looking for. So in order to solve this, I'm going to multiply both sides by cosine of theta. So then I have cosine of theta times this 3.846 is equal to negative 0.97. I'm going to divide both sides by that 3.846. And when I do that, I have the cosine of theta is equal to negative 0.243. Then to find the reciprocal secant, I'm going to take 1 over that negative 0.243, and I'm going to get the secant to equal negative 4.167. Just a real quick check. Whenever I'm doing these problems, Remember that the sine and the cosine can never be larger than 1 or smaller than -1. They have to be between -1 and 1. So if I got an answer that didn't meet that criteria, I would know that I would make a mistake. Just the biggest thing is make sure that you check your signs, the positive and negative signs. So when I'm doing this one, I might have started off at the beginning with that all students take calc. And then my cotangent's positive, which means I'm in the first or the fourth, and my sine is negative, which eliminates the first, which means I'm in the third quadrant, which means that the only two that should be positive are the tangent and the cotangent. Everything else should be negative. So my sine, cosecant, cosine, and secant. And those are. Okay, the next one is you're trying to simplify. So there's no equal sign, so you're just trying to condense it into one trig function. Remember, if nothing's squared, probably the best thing to do is change everything in terms of sine and cosine. So the tangent I'm going to write as sine of x over cosine of x. The cosecant I'm going to write as 1 over sine of x. Then I can see that the sine of x's will simplify, and I'm left with 1 over cosine of x. Don't want to leave it like that. I'm going to rewrite it as secant of x. Now b, the secant of x is 1 over cosine of x. The cosecant is 1 over sine of x. Remember, I'm keeping the first fraction the same. I'm flipping the second fraction. So when I multiply straight across, and I end up with sine of x over cosine of x, which I'm going to rewrite as the tangent of x. The next one, I have tangent of x minus secant of x. So this tangent is of 1. So what I might want to do is, so that I have a common denominator, I might want to multiply both the numerator and the denominator by tangent of x. So tangent of x over tangent of x. And when I do that, I'm going to have tangent squared x over tangent of x minus secant squared x. And I'm going to leave it like that because they're both over tangent of x. Then I am probably going to hopefully remember that I have an identity that says, one of my Pythagorean identities says that tangent squared, actually says 1 plus tangent squared x is equal to secant squared x. So in place of the secant squared x, I'm going to write this 1 plus tangent x. So I'm going to have tangent squared x minus, and then in place of the secant x, I'm going to write 1 plus tangent squared x all over tangent of x. And then I am going to distribute the negative sign. So tangent squared x minus 1 minus tangent squared x all over tangent of x. These two, positive tangent and negative tangent, will equal 0. So I'm going to be left with a -1 over the tangent of x, which means I'm asking for the reciprocal of tangent of x, which would be cotangent, and then it's going to be negative. That is one way. If you didn't remember this Pythagorean identity, then I guess you're changing everything in terms of sine and cosine and doing it that way. A little bit more work, but still doable. Okay, this one they want me to factor, so I realize that I have a cotangent squared x in both terms. So I'm going to say the cotangent squared x, and then I'm going to have 1 minus cosine squared x. And then I went ahead and simplified it. So this is cotangent squared x. 1 minus cosine x is equal to sine squared x. Cotangent is cosine squared x over sine squared x. And sine squared x, I'm just going to write over 1. And the reason why I write it over 1 is that I can easily see that it's going to simplify. And this whole thing is going to be just simply the cosine squared x. The next one, factoring this one, when I factor this one, I'm thinking of it like x squared plus 2x plus 1, except for it has tangent instead of x. I am going to product sum that, and that's going to end up being tangent of x plus 1. Tangent of x plus 1. So I just simply wrote tangent of x plus 1 and that whole quantity squared, and there's nothing else I can do with that. For C, cosine squared x minus 4, that's like x squared minus 4. That's the difference of two perfect squares. So I'm going to factor that as cosine x plus 2 cosine x minus 2, and that's all over cosine x minus 2. And I'm going to put that in parentheses so I can see that that's going to simplify. And I'm going to be left with cosine x plus 2. Again, you're not trying to verify, you're just trying to factor and then simplify. 4, I'm verifying. So I have trying to make the left side look like the right side. Remember, this equal sign is like a river or wall, something. You cannot cross it. You cannot add, subtract, multiply, or divide to both sides. So since I really have nothing else to do, I'm just going to multiply. I'm going to FOIL these two. So I'm going to have secant theta times the cosecant of theta. Then I'm going to multiply my outer, so that'll be plus secant theta. Inners minus tangent theta cosecant theta, and then the last would be minus tangent theta. That's me just foiling those two, and that's still going to equal the cotangent of theta. Then what I'm going to do is, at this point, everything's raised to the first power. I am just going to put everything in terms of sine and cosine. So secant is 1 over cosine. Cosecant is 1 over sine, plus secant, which is 1 over cosine, minus tangent, which is sine over cosine. Oh, times, let's see, times cosecant, which is 1 over sine, and minus tangent, which is sine over cosine. And I'm still trying to prove that's equal to the cotangent of theta. So what I did, and I don't know if this is good or not, but I did it. These have a common denominator. So off to the side, I'm going to write 1 minus sine theta over my denominator, which is cosine theta times sine theta. And then these two have a plus cosine. So I'm going to write those two together. So this will be plus, whoopsie, plus 1 minus sine theta over cosine theta. And I'm trying to show that that's equal to the cotangent of theta. At this point, I have two fractions, and I need to add them. I need to have a common denominator. So to have a common denominator, I have cosine here, but this one, I need the sine, so I'm going to multiply this by sine theta. So the first fraction is going to stay exactly the same, so it's going to be 1 minus sine theta. And then here's going to be the plus sign, and now I'm distributing this sine to this whole quantity, so it's going to be plus sine theta minus sine squared theta. And my denominator is going to be cosine theta, sine theta. And I'm trying to show that that's equal to the cotangent of theta. Here I see that the negative sign and the positive sign will equal 0. So I have 1 minus sine squared theta over cosine theta, sine theta is equal to cotangent theta. 1 minus sine squared I can write as cosine squared theta. Cosine theta, sine theta. And at this point I'm going to rewrite cotangent as cosine theta over sine theta. Here the cosines will simplify 1, and then I'll be left with 1. So I'm going to have the cosine of theta over sine of theta is equal to cosine of theta over sine of theta. So I've shown that the left side is equal to the right side. Now give me a second so I can go grab that other one. Okay, so the next one, as soon as I see this pi over 2 minus x, I'm thinking cofunction identity. So the cotangent, that will be tangent of x times the cosecant of x is equal to secant of x. So I'm going to rewrite everything in terms of sine and cosine. So the sine is sine of x over cosine of x. The cosecant is 1 over sine of x. And the secant I'm going to write as 1 over cosine of x. Here I can see the sine of x simplifies, so I have 1 over cosine of x is equal to 1 over cosine of x. Remember, different ways of doing this. You could have kept the secant the same and then just rewrote this as secant. Still, as long as the left side looks exactly like the right side when you're done. Okay, the next one, I have cosine squared beta minus sine squared beta is equal to 1 minus 2 sine squared beta. I look over here and I see that everything is on this side is in terms of sine squared. So I want to rewrite this in terms of sine squared. So remembering from my Pythagorean identity that cosine squared is equal to 1 minus sine squared theta, well, this is beta, minus sine squared beta is equal to 1 minus 2 sine squared beta. Now here's my 1. I have 1, 2 of these, so minus 2 sine squared beta is equal to 1 minus 2 sine squared beta, and I'm done. The next one, I'm first going to take care of those negative parentheses by doing the even odd. Cosecant is a reciprocal of sine, which makes it odd. So this is going to be 1 plus a negative, if I want to write it like that, which I probably should. So this will be 1 plus a negative cosecant. And then cosine is an even function. So the cosine of negative theta is just going to be cosine theta. And I'm writing x, so sorry. Cotangent is an odd, so this will be plus a negative cotangent x. Okay, I switched my thetas to x. I hope that doesn't bother you. Secant x. Now I'm going to try and write everything in terms of sine and cosine. So this will be 1, and then this will be minus, taking that negative sign for sine. I'll switch it back to theta. And then cosine is just cosine. And then minus cotangent, which is cosine over sine. And I'm trying to show that the secant, which is 1 over cosine. So you might probably separate this into 2. So in order to add these 2, I need to have a common denominator, which is sine. So I'm going to multiply this 1 by sine theta over sine theta. And when I do that, my numerator is going to be sine of theta minus 1 over sine of theta. In the denominator, big line for denominator, in the denominator, this is understood to be over 1, so I'm also going to have to multiply by the sine of theta, to give them a common denominator. And when I do that, I'm going to have sine of theta times the cosine of theta minus cosine of theta, and that's all going to be over the sine of theta. And again, I'm trying to show that it's equal to 1 over cosine theta. Forgot to change it to theta. So leaving the top fraction alone, taking the reciprocal of the other fraction, so this will be sine of theta over, and while I'm here, I'm going to factor out a cosine theta if you don't mind. So I'm going to have sine of theta minus 1, and I'm trying to show that that is equal to 1 over cosine theta. Here I can see that the sine of thetas will simplify, and the sine of theta minus 1 will simplify, and I'm left with 1 over cosine theta is equal to 1 over cosine theta, and I am done. Probably should put that in parentheses. Okay, moving on to the next one. Oh, I'm done. All right, I'm done. Hope this helps, and we'll see you next class.